Alright, welcome everyone. Today we're going to be tearing down an EcoFlow River 2. This is just the River 2, not the Max or the Pro or anything like that. A little schmoo on the top there, that won't hurt nothing. Never taken this thing apart yet, so we're going to kind of explore and learn together. Of course, if you're going to do this at home, do it at your own risk. These are batteries, they're LFP batteries, but they're still not 100% safe. You still want to be precautious. You don't want to short them out. Nothing should happen if you short them out, but the best prevention is just not to do it at all. So we're going to try to get into this thing, and main goal is to see what the battery voltage is, maybe the manufacturer company of the batteries, and see what others we can find. So it looks like these, just as I thought, are just kind of clip fit in there. Alright, just turn it off though too. It is fully charged. On a normal lithium battery I would be more afraid of it, but on this one I'm not super worried. Just don't short it out. Just don't, hurt yourself. Alright, so let's see. Phillips screws. No surprise. Never where you need them. Never where you need them. Alright. Here we go. Let's get in there. Luckily, it doesn't look like they're using any scum tactics on trying to keep you out, like stickers on top of seams or anything like that. I might be proven wrong, but we'll see for now. Alright. Oh, okay. Let's see what's going on in the back here. Just a clip. And there we go. Just inside the top. There's like the inverter board, charge board, all that stuff. See what we can see in here. So it looks like, yeah, not too bad. Everything looks like it's mostly conformal coated. See if I can get a pokey bit to poke at stuff. That didn't sound good. Alright. Some small little transformers in here. Relays. One thing I'm not too super happy about would be stuff like this. More of a permanent fuse right there. Yeah, so that's like a permanent fuse. Looks like that's on the AC or the AC side. There is a clear division between the AC side of the board and the DC side of the board, you can see. It's like kind of right down there next to this heatsink. It's got a shared ground between both sides. That's good. So this is all inversion or inverter stuff. Nice big capacitor. Everything has this elastic stuff on it, holding it in. Nothing's really loose, that's good. It's got a giant ferrite right here on the wires from the board to the actual socket, so that's going to reduce a lot of electrical noise. That's good. So these must be the transistor that it uses to generate the waveform and to use the waveform from the wall. See if we can get down to the battery itself. The only thing I'm worried about is a lot of batteries. If you disconnect the BMS board, it goes into protection mode. Just have to be really careful not to disturb it. Oh, okay. So there's like a... Interesting. So it looks like right here is... There's two DC, like, I guess bus bars. They're kind of slid into these prongs down here. So you can zoom in there. Kind of in these prongs. And it's got this cover holding them down. And that cover has like Celastic on it. Keep it in there. I don't want to destroy this thing, but I really, really do want to see what the battery looks like. Alright, let's try it. I don't have an electrician screwdriver here with me, but the amount of Celastic on this, just gotta make sure I don't touch any exposed. I wouldn't want to get in between those two things, but luckily I don't think I have to. Looks like the center ones are the ones with the washers on it. The outer ones don't have any washers on them. It's pretty nice. Fasteners though, I mean, the only thing I don't like is how some of the fasteners go straight into plastic. They're like the coarse thread. I wish they were all, you know, sunken nuts. Kind of like right here, and right here, and here, and here. Those are really nice. Okay, let's see. One in the center, probably. See if we can get any manufacturers off of this to get to. Here's the neutral line. To make sure we get that back, of course. So Celastic is great when you want to make sure that nothing moves around, especially for being how portable this unit is, but it also kind of sucks for repairability. Okay, this is the inverter socket plug-in. There is a little bit of an uncomfortably amount of stress on that cable right there, because it was like that. I don't like that. I'll probably secure that a little bit better with some hot glue or something. I'm interested to see what kind of connections they use to the battery, as well as maybe a battery manufacturer. I don't fully expect to be able to see it. Probably pretty covered. That's worth a try. Probably the fan. Oh, this whole back thing comes out. Oh, that's nice. Alright, so the whole back cover with the fan. Well, in case you want to change the fan to a quieter fan, because this is probably the most annoying part of this unit, is just this fan and the noise that it makes. I really don't think they're high quality bearings. But, I mean, it seems like a kind of a semi-standard fan. And it exhausts out the back, so it looks like the air comes in the front. Let's see. Set that aside. That one's kind of trapped under this elastic. There we go. Oh, there we go. Interesting. All right. Okay, so those came off that pin nice and easy. It's not bad. So there's those giant pins on the front board. Here's the front board for you. And then here's the main board. leave you alone. I'm just gonna chill there. All right, so here is what I assume is the BMS. There's a lot of good contact with this board. This one looks a little bodgy. I mean, it's on there, it's secured, but quality probably could be a little bit better on that. So these are all probably for measurement. There's a lot of shunts and stuff. It's all conformal coated right here. It seems like they just conformal coated the center here, which, I mean, that's better than no coating. Looks like we got an 80 amp ceramic fuse right here. I mean, that's like worst case scenario. If you're blowing the 80 amp fuse on a River 2, you're probably not doing something right. Oh, so they're the large format. Okay, so these are the large format cells. See, these are definitely not 18650s. Kind of seen through here. I believe the Anchor power bank uses the same. I'm going to be taking that apart sooner or later here. But it looks like there's 1, 2, 3, 4 of these bigger cells. See if we can get a voltage measurement on them. I'm curious to see what they are. Can I pop this? Oh yeah, there is. Okay. 4 more. So these, that's nice. So the screws that hold down the pack are like set in nuts. So that's actually really nice. Built in. Oh, here's a date on here. 6/08 of 2022. If I remember correctly, the River came out in 23, so they must have started building these pretty early, because that's, I would assume that's a date. It doesn't really look like anything else that could be. So, I mean, all this writing in here is probably just QC writing. They usually just mark connections when they're done with soldering them or whatnot. Oh, okay. So here's the pack. Let's get you out of the way. But we'll appreciate the internal geometry here. That's pretty nice looking. All these hexagons? Yeah, 1, 2, 3, 4, 5, 6. Yeah, hexagons. Cool. Looks pretty sturdy. So let's take a look at this pack. I don't see any brand on these cells or any writing at all, to be honest. It's interesting. So you can see in between the board here and the cells. No, I don't see nothing on them. I was kind of hoping to see some kind of brand or something on them. I have to do some research on what kind, but these are massive cells. I mean, these things are huge. What can I put in to compare? Americans want to do everything but the metric system, I'm sure. Let's see. Tape measure. It's about 1 banana long, says the internet. That's useless. It's only standard. Who wants standard? This boy is stupido. 140 mil? Yeah, I'd say around like 140 millimeter. So 140 by 45. You know, I totally forgot. I'm gonna have to put that in the video later. But these are massive LFP cells. See what kind of voltage they're running these at. Not everybody can have a fluke everywhere. All right. So let's just do B plus, B negative. So let's see what the actual BMS sees. Oh, so it's a 12 volt. Well, yeah, 13.3, but you know, 12 volt, 0.3. Yeah, so this is fully charged. They're about 3.3 volts. Yeah. 0.3, 3.34, yeah. 0.34. 8.34. Yeah, so it's a 12 volt pack. I would assume that the River Max is probably like 24 volt pack. It is double the capacity. I'm not sure if it's going to be double the voltage. It's going to be something I'll find out when I take it apart. We're going to start with this guy and we'll work our way up. Eventually I'll get to the Delta Pro and we'll be measuring that stuff. Yeah, I'm stupid. It's these. So those posts goes through, yeah, I don't know why I didn't see that earlier. Goes through the board right there. See how they're the metal, those metal holes right there. Those go through the board and end up right here into, and basically that screw goes through those. So those are really important to make sure when you put them back that they are tightened correctly and that there's no shmoo or dirt on top of them. I would also best guess, I don't know why they're so thick, but maybe it's just easier to manufacture them that way. The difference in voltages then, because this is the only path that looks like the voltages come out, and this just says NTC positive negative CXWP. So I'm guessing this is communication from the BMS to the board for the screen to tell what percentage and everything like that, and overheat any error messages, you know. These would be like for it to check balance between cells, so it can monitor this is positive, we'll say this is cell 1, 2, 3, 4. This would be like positive 1, negative 1, and then that's going to go in series to B2 positive, and then negative, and then it has a bus bar that goes between them to the positive on this one. So it's series. So series is a pretty simple concept for you for those of you who don't understand. Essentially, when you stack batteries, positive to negative, and with the end result being the negative of one battery and the positive of the other battery, you're going to stack voltage. It's going to be the same amount of amperage capacity coming out, but you're stacking voltage. So more voltage out, I mean, it's going to be more efficient, less heat, everything like that. It's fairly heavy. I don't have a scale up here, but it looks pretty good. Let's see if I can get like any kind of manufacturer off of any of these. ASTN, not sure about them, never heard of them. Off these IC packages, I can't really see too much. I'll look at this number up later, see if there's anything relevant that comes up from this. This MR600 UV BMS. It is EcoFlow watermarked, so it's not some off-the-shelf unit. Alright, so let's see what we got here. Let's see if we can put it back together a little bit better. So this would be the little Wi-Fi module. This is how it connects to the internet. I'm assuming it's probably like a combo unit with Wi-Fi and Bluetooth. Looks like that's the only antenna that I can really see right now. That'd be the antenna right there. This chip looks like what the driver for the display. Interesting. Pretty good size heat sinks for those little transistors. The MPPT is on this side. It's going to use the transistors and the transformers to step up and step down voltages for like solar and stuff like that. Very nice. What kind of brand do we have on these capacitors? RUC. They'll look those up. Not entirely sure about those. Aisha, Ishi, AISI or HI for that capacitor. Probably Chinese. Okay, let's see if we can get this back in here now. We'll see if before we put it all together, ultimately we'll see if it turns on still, because that's you know, important. This looks like little guideposts right about right here. It's kind of nice of them. So these are the ones that go to the main pack. These 2 screws. It even says negative and positive on them. I should have seen that earlier. Make sure those are decently tight. Not going to break them, but you know, those ones are the most important to really be tight. As well as this ground one. You really want that ground one to be nice and secure. You don't want a loose ground, or well, neutral in this case, but you know what I mean. So I remember the front panel shares the ground with this right here. Make sure those spades are nice and tight. Yeah, that's nice and tight in there. WP, ground, NTC. So I'm not sure what WP is supposed to stand for. I'd have to look it up. But it is nice that all these lines are heat shrunk. So like when it comes up next to the board right here, it's not gonna chafe on the board as much or anything like that. Let's plug in this inverter one. Make sure it goes the right way. This does share the negative here. It's not contacting anything else. It's good. And these guys are bonded together. So it does seem like there's really good shielding in here, as well as really good like safety features, like plenty of safe grounds, things of that nature. Get those nice and secure. Secure. Now let's put all these screws back in. And before we put the lid back on, get the fan in there and check to make sure it works. I'm also going to post some videos of, you know, tests like capacity tests. I've done capacity tests in the past for EcoFlow batteries. They come out pretty industry standard, around 80% of your output that you'll get. Around 80% of the rated capacity. That's pretty normal for a lot of these power banks. That's not like a crazy thing or conspiracy. That's just how they rate batteries. Negative, positive. Let's see. Yeah, just as happy as before. I think I gotta hold it. Test all the outputs on there. I didn't notice before though, and I do notice it with the cover off, because there is a slight whine from the inverter board when the inverter's on. Okay, let's see. Switch to AC. Not as good with AC as I am with DC, but 120. That's what I figured. That's a lot better than the Anchor batteries. They run at 110, which is, there's nothing wrong with running at 110, but if you like hook up fans, heaters, things like that, it's not going to feel like they have as much punch. You definitely will notice between hooking up to a 110 versus a 120 on like things like fans, things that get driven directly off of the AC voltage. You'll notice that like the high speed will be a little bit slower than what it would be normally on like 120. Yeah, there we go. So 12.66. I don't know why it's not the full pack voltage. Maybe it's getting regulated down, because I believe the full pack voltage was like 13.3. Looks like we have some blinking lights going on in here. They don't say what they are, they just say LED 1 and 2. It's not like they're anything specific, it looks like. I'm guessing they're just, status lights or something to that effect. Oh, wait, no. That must be the AC one. This just must be like on in general, I suppose. So if you turn on the AC, yeah. So that must be like powered to the inverter. It's a pretty teeny inverter, but you know, for its size, it's actually pretty impressive because I believe it's 300 watt is around what it does, and then with the X boost, where it lowers the voltage and raises the amperage, it's about 600 watt. So that's pretty decent. Make sure that's in there. You don't touch the both sides of that, you know. So that's in there good. Yeah, so I'll turn that off. Turn the whole thing off. Seems like it takes a second for that inverter board to go to sleep. I'm wondering if it's just draining capacitors before it goes to sleep. Let's see. I'll get the cover back on here. Everything seems secure. Okay. Very nice. So far, I'm pretty, I mean, especially for the price of this unit, I'm pretty impressed with the build quality. Because there's some of them that are just not nearly that quality. And I get it. You know, I mean, you're not paying like $1 million. It doesn't have to be aviation grade piece of equipment or whatever, but at least with batteries and the environments that people are going to be using this in, you know, you're going to want it to be at least pretty decently durable. Alright, hardest part. Figuring out where these clips go. Oh! One went flying, that's where it went. Are they all identical? Oh, maybe it's not going to be that hard. I think they're odd. I don't know why I thought they weren't identical. Just kind of slip in there. They don't like clip even. Suppose that's not super bad though. Clips can be really annoying. There you go. Make sure this still works. Yeah, it's happy. 60 hertz. So let's see. See what happens while we unplug it. Some guys out. Yeah. So it goes up like about a volt. You unplug it. Very nice. And that is the teardown of the River 2. Very handy little unit. You can even lift it with a pinky. 256 watt hour. Yep. If you guys are wondering, here's what the specs are. Whoop. Pause it if you want once it focuses. Thanks for watching.